So good evening. My name is Bea Burks and I'm a climate scientist at Marine Scotland Science. And today I'm going to talk about fisheries and greenhouse gas emissions and addressing net zero goals. I should say, as a bit of a caveat, I'm a scientist working in government, so my talk won't focus on much policy direction or policy making, but instead I want to highlight some of the information and evidence that scientists like myself, but also collaborating with people like Tara and Bill, are kind of introducing into government to inform them, but also with key stakeholders to build a kind of collaborative network of information and decision making. So what are greenhouse gases? Probably most of you are already familiar, so apologize if it's a bit repetitive, but in case you're not, greenhouse gases are gases that trap the sun's radiation inside the atmosphere. And so they're often likened to putting a warm blanket around the planet. Some are naturally occurring and they play a role in our natural climate, and some are man-made. But since the start of the Industrial Revolution, humans have been increasingly adding these greenhouse gases to the atmosphere and therefore trapping more radiation inside the atmosphere and warming the planet. And so the graphs on the left that you see here are atmospheric measurements of 4 of the main greenhouse gases: carbon dioxide, methane, nitrous oxide, and sulfur hexafluoride. And these measurements are made by NOAA, which is the National Ocean and Atmosphere Administration in the United States. And you'll see not all of these measurements start at the same time. As we've kind of identified more greenhouse gases and their role in our climate, we've started collecting these measurements. And you can see that all of these gases have increased in concentrations in the atmosphere, causing climate change. And in their latest report, the Intergovernmental Panel on Climate Change, the IPCC, show clearly that the warming of the planet is due to human influence. So these different lines show model simulations and observations of temperature, global surface temperature. So the green line is when it's a simulation using only natural processes, and that includes solar and volcanic activity changes. And the brownish line is when you include human factors, so greenhouse gas emissions. And then the model simulations actually very closely agree with the observed surface temperature changes, and that's the black line. And the report also said that the rate of change is unprecedented in the last 2,000 years. And to stop these changes, really humans must reduce their emissions of greenhouse gases. So this is a timeline showing some of the key dates in the IPCC from its inception. Can you still hear me? Yeah.
It's gone a bit funny, Bea.
Oh. Can you hear me now?
Yeah, keep talking.
Yeah, okay. This is a timeline from the inception of the IPCC in 1988. And it shows some of the key framework agreements and legislation at the global and national level. So the IPCC process is collecting the scientific evidence base, and then alongside that, there is the United Nations Framework Convention on Climate Change, the UNFCCC, which was established in 1992 at the Rio Earth Summit. And under the UN framework, the Kyoto Protocol in 1997 provided the first binding agreement on greenhouse gas reduction targets. In 2015, so that's further down, almost in the near to where we are now, in Paris, there was a first legally binding climate deal with the ultimate aim of keeping global warming to well below 2 and ideally 1.5 degrees Celsius. And the 1.5 was really brought on by evidence from the IPCC that that was a key threshold in the climate system. So in order to achieve this, countries must reduce their greenhouse gas emissions to net zero by 2050. Within the UK and in Scotland, climate change legislation was introduced in 2008 and 2009 respectively. And Scotland is actually one of the first countries to set into law a legally binding target of net zero emissions by 2045. And at the end of last year, in 2021, Glasgow hosted the annual conference of the parties under the UN Framework Convention for Climate Change. And at that summit, the signatory countries made further agreements where they're really trying to keep that 1.5 target alive. So where do greenhouse gases come from? They're released through our use of fossil fuels, for example, in transport and industry, but they're also released from our change in land use and from the production of animal protein. And we also already have the knowledge and technologies to reduce our greenhouse gas emissions. For example, we could include more energy from renewable sources like wind, and we could encourage more carbon uptake from natural processes such as tree planting. But how do we actually calculate these greenhouse gas inventories? To investigate this, I first want to introduce you to two more technical points, which I hope you will humor me with. So the first one is that not all greenhouse gases result in the equal amount of warming for our climate. So these circles on the left show the amount of warming that a ton of each of the greenhouse gases would have relative to 1 ton of carbon dioxide over a 100-year period. And these are the 7 main greenhouse gases that are required to be reported on under the Kyoto Protocol. And so you can see that some greenhouse gases have a very high global warming potential. And by converting all of the emissions from each gas to the equivalent in carbon dioxide global warming potential, we can actually make more easy comparisons between them, and we can add them together, creating these inventories. And that means that the impact of all the greenhouse gas emissions on a global scale can be expressed on a uniform scale. Luckily, so some of the greenhouse gases which have the largest global warming potential, like the sulfur hexafluoride, nitrogen trifluoride, and the fluorocarbons, they actually are also the ones with the lowest emissions. So luckily, their contribution is relatively small. And carbon dioxide is actually still the largest contributor. So the bars on the right show the global the contribution to global emissions for each of the gases. In 2016, that was the most up-to-date data I could find that was easily transferred. And so methane and nitrous oxide are the second and third most important ones. So the next point I want to also highlight is that we need to consider how to quantify these. So sometimes how we quantify these from the different activities. So the international scientific community through the IPCC has put forward guidance on how to calculate greenhouse gas emissions. They update their protocols regularly to try and include more processes in more detail, or to include new processes that as we broaden our scientific evidence base. And so they classify them in 3 tiers. Tier 1, right at the bottom, is the most basic approach, and that uses international emissions factors, requires relatively little data on the activity, and then can calculate emissions from that. But that actually really results in a large amount of uncertainty. On the other hand, if you have a tier 3 methodology, that takes in much more detailed information on individual processes and facility-specific emission factors. And so that requires a lot of data and information, but it also gives the smallest amount of uncertainty. And so throughout my talk, I'm going to share some results from different methods relating to fishing, and you'll see this infographic again. So the Scottish Government publishes an overview every year of the quantities and sources of greenhouse gases, and these are the national inventory. In 2019, total emissions were 47.8 million tonnes of carbon dioxide equivalent, and we can see that the majority of greenhouse gases are due to carbon dioxide emissions, and the main sectors that are contributing are transport, business, agriculture, the energy supply, and residential components. But the national level accounting lacks some of the detail that's required by individual businesses or policymakers relating to specific aspects of the marine economy. So it can be difficult to see how activities because of aquaculture, fish processing, freshwater fisheries, or marine renewables are translated into these high-level sectors under national inventory. And today I'm going to focus a little bit more on the emerging work on how we quantify emissions from the fishing sector or fishing activity, and try to tease some of the detail out. So let's take a closer look at which activities release greenhouse gases from Scotland's wild capture fisheries. The range of activities that emit greenhouse gases cover the entire supply chain of the fishing sector. So it includes emissions from the construction of the vessel, its upkeep, and that includes maybe painting the boats or their fishing nets. It also includes emissions from fishing operations through fuel, oil, refrigerant use. And then there are emissions related to waste outputs to the soil, water, or air throughout the processes. And various activities after the delivery of fish to the quayside. So fish processing and packaging, its transport, but then also emissions relating to retail and consumption by us. And then at the end of a vessel's life, there are emissions relating to its disposal and recycling. So you can see that calculating the emissions across the entire operation could be very complex. And some of these emissions will fall within our own country's national inventory, but some won't. And for example, if you buy a paint from overseas for maintenance, then that's an imported product, and the emissions to produce it and maybe even to transport it would be accounted elsewhere in the global emissions accounts. But as a business, what you might want to know is whether there's a different supplier who can give you a much more climate-friendly paint. And so it's in the interest of businesses and even policymakers to know some of the underlying detail to meet their own climate ambitions. And so that can be done through using a life cycle assessment across the entire life cycle of a product, and that's kind of what this wheel is showing. So in the between 12 and 1, you can see the kind of start of a vessel, its construction, and then it goes all the way around to its disposal. And for each process, that requires knowledge of the inputs and outputs, but it also requires knowledge of models to represent the emissions from the processes. And earlier in the talk, I mentioned that different methodologies identified by the IPCC. And so this is an example of a tier 3 method where we need the greatest level of complexity and data, but that actually results in the least level of uncertainty. And it provides an opportunity to identify where processes are maybe large contributors to emissions, and therefore where we can maybe prioritize action. So what does it tell us about the emissions from the fishing, And to do that, I should first say that we don't have many of these detailed life cycle assessments yet, but a great example are recent results from Francis Sanderson and colleagues who are based at Aberdeen University for the Scottish pelagic fleet, or Scottish pelagic vessels. And they undertook a very detailed analysis of 11 vessels in the fleet, and they did analysis of the emissions from the beginning of the process, so the cradle, all the way to the quayside, using one of these detailed calculation methods. And what they found was that the largest contributor by far to greenhouse gas emissions was fuel use by the vessel, almost 96%. So these detailed results have highlighted that looking in a first instance at fuel use by fishing vessels could give us a fairly comprehensive overview of emissions. Go the right way. And so the example from the pelagic fishing fleet has led us to start thinking about emissions from some of the other types of fleet that operate in Scottish waters and trying to do a similar analysis. And now we're using a much simpler method, more akin to what the tier 1 methodology would be within the IPCC framework. And so we've used, this is some analysis which I've started to do myself together with Tara and other colleagues. And so we've used data across the segments of the fishing fleet from sea fish to calculate greenhouse gas emissions from fuel use. And that's the bars you see on the left. And when we look at patterns in the fleet segments, we can see that total greenhouse gas emissions are generally larger when they land more fish, have a higher income from fish, consume more fuel, both either as the individual vessel or as the total for the fleet. And there's some factors where greenhouse gas emissions are lower if they spend less effort, so less days at sea, if they have a higher value per fish, then they actually tend to also have lower greenhouse gas emissions. And the number of vessels in the fleet and the vessel age also start to show us some interesting patterns. And we're still working up on the results, but one thing we have identified is that the emissions estimated for fishing in the national inventory using a different method are actually lower than what we find from our fleet analysis using the sea fish data. So there are differences in methodology, and it'll be interesting to find out what that means, whether we need to maybe think about revising methodologies to do some of our national accounting. That's one kind of outcome. And I should caveat our analysis that it is based solely on fuel consumption. Oh. Yeah, sorry, lost my thread there. But it does give us an opportunity to identify which types of fleet would actually benefit from a bit more detailed analysis. And in the future, we're also hoping to look a little bit around how these emissions relate to where fish are landed in Scotland. And so that could identify certain hubs to support local action. So there are some caveats with our results, but one emerging outcome is also that greenhouse gas emissions from fish is actually relatively lower than those per yields of protein than some other sources of protein in our diets. So the kind of reddish bars are all from farming animal protein sources. The green are farmed vegetable, and then light blue are aquaculture, dark blue are fisheries from a different analysis, and then the light blue, the kind of in-between blue, is from our own analysis. And it's showing that clearly the certain fish types, such as pelagic fish, which Tara already mentioned, are very climate smart choices because they have a relatively low amount of greenhouse gas emissions per 40 grams of protein. Others are less so. They seem to be a little bit more intense, and these include some of the shellfish and crustaceans. And these conclusions should be hedged a little bit in that these estimates are from fuel use only and based on a cradle to quayside approach. So we're not looking at emissions from retail or packaging or any onward transport. And ideally, we'd like to find out more about emissions across the entire supply chain. And so that's really trying to look at sustainability across the supply chain. And finally, I should say that some of these also come with, this is only looking from a climate perspective. There are other factors affecting sustainability and environmental impact that should probably also be considered thoroughly. So fisheries have a relatively small carbon contribution to emissions in Scotland. But increasingly, as we're reducing the national total of emissions, these small contributions will become relatively more important. And so it will be, I think, reducing emissions from the activity of fishing is likely going to be needed. And I'll come to some solutions in my next slide. But at the same time, the product, as Tara mentioned, of sustainably caught fish with low greenhouse gas emissions could be an important part of, say, changing our diet. Even though a majority plant-based diet is the recommendation, increasing your fish may also help. So how do we achieve reductions in emissions from the fishing sector, or how could this be done? It could be done through innovation and shipbuilding technology, changes in the fishing gear, increasingly sustainable fishing practice, and measures including financial or spatial management or effort management could introduce could reduce emissions from fishing, as could accreditation related measures could potentially drive change, and conservation practice as well. And there's always going to be benefits of doing these things, not just for emissions, but for other parts of the economy or other parts of the environment. So it's worth trying to take a holistic approach across this. But as I mentioned at the start, I'm not a policymaker. My role is to identify evidence to then inform government and its stakeholders, and identify. I hopefully have highlighted that there's many unknowns still out there that we're trying to get information on, so that we can make those decisions in a informed basis. So with that, I think it's time for me to say thank you again to the organizers for asking me to speak tonight, and I'll happily answer questions at the end, and I'll pass over to Bill.